everybody. My talk is about RAG. It's not that original. I heard like 2 or 3 talks about RAG, but I hope it will be a little bit different from others. This is mainly about RAGtime, which is a personal project of mine for basically teaching purposes for this PyCon Italia, and it is built on Haystack 2.0, which is a new release of Haystack, which has been released like 2 months ago, if I remember well. So this is the outline of my presentation. The first part of the talk is about Retrieval Augmented Generation as a topic, just to be everyone on the same page. The second part is the advanced implementation of RAG. I selected just 2 of them, advanced and modular. Then I'm going to talk about Haystack, the fundamental building blocks, at least useful for building a RAG, and then we are going to see in the demo. So. Few words about me. I'm Tommaso Radicioni, as I've been presented. I have been a PhD in data science at Scuola Normale here in Pisa, not far from Florence, if you are not from Tuscany. And I'm currently working since 2022, if I remember well, in NOU, which is a team in working on NLP within the Galaxy of Digitiamo, which is a startup in Milano Varese. So, RAG, Retrieval Augmented Generation, has been first introduced as a term 3 years ago in a paper in 2021. Basically, it has been introduced since we had these large language models. They have strong capabilities in generating coherent and semantically correct text, but they have knowledge which is related of events or of some sort of knowledge before the training. So it is not updated until the next training. So we can ground the information of the large language models with an external source of knowledge, or many external sources of knowledge. This is an example of what is a RAG, simplified scheme, and a lot of improvements in the last 3 years have been made. So let's start from the very core of the RAG. So basically, I asked to ChatGPT, for instance, a recent event, such as the dismissal of OpenAI CEO, and in the best case, it could answer the truth. So I'm not able to provide an answer like this one. But in other case, the response is totally incorrect, is what it is called an hallucination, so an incorrect answer. And for this reason, we build 3 components of this retrieval augmented generation. The first one is the indexing. So we have tons of data. We have tons of unstructured data like PDF, TXT, and so on and so forth, and we extract only the relevant information, so the textual information. We chunk, so we divide it in small vectors of text, and then we embed this text and we store in a database here, this part of the scheme. The second part is the retrieval, so final user type a query, and the retrieval model is able to retrieve the top K most similar documents to the initial query. So if I ask about the OpenAI CEO dismissal, I got these 3 texts. And the last part, the part where the LLM is actually involved, so the generation part. So I asked to ChatGPT or another LLM model, please answer the above question based on the following information with the information I got from the retrieval part. So the magic here is the augmented prompt. So instead of having just the question, I augment my prompt with some information I got from the retrieval part. Yeah, cool. Hallucinations are reduced in LLMs generation. We can even trace the components, so the output of each component can be traceable, and it's a very it's an advantage for us, because before RAG, the LLM was an output, black box, and then an output. Here we have some different component with a partial output. But even in the naive RAG implementation, we miss some points. So there are missing information in the retrieve docs. If the retrieval model is not so convenient, the generated output can be irrelevant, biased, or toxic, or even more, if we combine issues in the retrieval and in the generation part, the output can be incoherent or disjointed. So there have been, I classified the advanced RAG in two different categories. The first one is called just advanced RAG. And there have been some optimization strategies in basically two phases, the pre-retrieval and post-retrieval. So the scheme is the same as we already seen before, but we enhance basically two parts. The pre-retrieval, so the indexing part, we add, for instance, metadata information in the indexing, so that we can improve our retrieval. Or we expand or we optimize our query to get better results in retrieval. The second part is the post-retrieval. So we have our documents, we can, for instance, re-rank them. So we have top K in an order. We use another another model called ranker or re-ranker, and we can arrange in a different fashion, in a different order this document, or we can compress, so reduce redundancy and compress information fusing combining different outputs. Another one is the modular RAG. Modular RAG is basically we take the structure of RAG I explained before, we add new modules or new patterns. New modules is in particular the part of the retrieval or the processing of the query. So we add, for instance, a routing module or a search module. So we instruct our RAG to route information in different tasks or in different search modules for looking in different data structure, in, for instance, knowledge graph, or new patterns. So we take the retrieve and read mechanism, which is fixed in the RAG I've explained before, and we change a little bit this mechanism. A popular one is the self-RAG, so the self-reflection. The RAG reflect and made a critic of its own retrieval, and it can repeat the retrieval part, or the hypothesis document embedding. So the RAG is able to create artificial document and embed these artificial documents and take not the query but those documents to retrieve documents. So can be useful for improving retrieval. I added this slide because a lot of people told me about why fine-tuning, why not fine-tuning a model instead of using RAG? Well, they are two different things, actually. RAG, I think it's highly dynamic. It can be used, it could be added, knowledge, source knowledge even on the run when you have a RAG in production, for instance, and we have external knowledge sources. It's like buying a new textbook. So if I had a quiz, if I had to solve a quiz, I can solve it by looking at the textbook, but just for a temporary piece of knowledge, and then that's it. that knowledge is just for the quiz, and I don't want this knowledge to be incorporated somehow. But fine-tuning is different. Is more static, but is able to deep down to change the large language model. So it encapsulates in the large language model the behavior, the style. So it's another pre-training. You can do just a few times. The RAG is dynamic. You can change whatever you want. The fine-tuning is one for all. Is because it's costly, time-consuming, and so on and so forth. The RAG can be even evaluated by themselves, by the LLM themselves. I think this is really useful for in production for RAG, you can use in production for softwares, and those 3 quality scores, I think they are the most useful. I strongly suggest them. The context relevance is basically the relevance of the retrieved context given the question. So I ask some question, I took up a piece of text, and I would like to extract just the relevant part of the context which is able to reply to that question. The answer faithfulness, so the consistency of the generated answer with respect to the retrieved context. So I have an answer, and I would like that the generation is able to do really well that answer, and the answer relevance, which is the same thing of the context, but for the answer. So the pertinence of the generated answer given the question. So I would like that the answer reply in a good way to the original input. Here I put some library which can be useful, Ragas, TrueLens, and dpval, but there are many more. Ragas and dpval are integrated in Haystack. TrueLens is not, if I remember well, but yeah, they are useful. I strongly suggest to try them. Yeah, let's talk about Haystack. I work with the Haystack library since I think August 2000 and August of the last year with I Know You, and is a really I really like this framework. It's an orchestrator which is allow us to build various NLP applications. I think that there are three main advantages to use Haystack. Just to be clear, I'm using Haystack, but there are even other technologies as Llama Index, LangChain. I more get used in that, but I suggest even to try the others. Because I don't think there is so much difference. Go with what you like. And yeah, Haystack, I think that can be easily integrated with different LLMs, with Llama, with OpenAI models, coherent models, and many more, and many technologies, tools, and so on. You can build a complex pipeline using with the same library many tools, converters, embedders, retrievers, generators, and so on. And it is really really easy to build pipelines. Yesterday, Stefano told us how it's very easy to do that. Yeah, fundamental building blocks are those ones. Components are modules, basically modules that perform a single task, the preprocessing, the retrieving, the conversion of file. They can take the outputs of other components since each component has a run method. So it is really easy to put them together in a pipeline, which is a directed multigraph. And this is really cool to have a directed multigraph because we can even branch the outputs in different line of codes. Then they merge together at the end. So there are pathways really complex in the pipelines, and loops are even allowed. So it's cool that the output can be the input until we are satisfied. And this is an example. Okay, let's go. 10 minutes are left, so we have to go to the juice of this presentation. So the RAGtime is a Streamlit-based application. So I think that everyone knows Streamlit. You can scan the QR code to get the demo code base, even the slide actually, not only the demo. And the main tech stack are 3 libraries. Haystack, which is the LLM orchestrator. Hugging Face for the model, because it's an open source platform, and I think this is useful for this presentation. And Coherent, which is an efficient vector database. I had the opportunity to prove the efficiency. I'm not working actually with Quadrant, but I think it's a cool technology. RAGtime is easy to be installed with Docker. I put the installation guide, so if you want to test in your laptop, is okay. Okay, let's start the demo. I hope it will work. Okay, this is RAGtime. I can ask about, okay, it's not, how can I charge? I have camera, and I would like to charge the battery of this camera of my Canon, and there is no documentation here. I'm asking just to this LLM, Hugging Face H4, the Zephyr 7th billion beta. Okay, let's ask. We will see what, without any documentation provided, what is the answer. It should be this one. Okay, no, I'm sorry. This was the last part. Okay, no, there was the documentation. So in Coherent there was already the file, but I was okay. I wasn't prepared to that, but okay. The demo is already like that. Okay, yeah. The documentation was on in Coherent. I put the PDF just like that. So I use the converters provided by Haystack, and that's the response. I think that it's a good response. The original file was this one, and yeah, it works. But I'm sorry, I didn't delete the documentation before, because it was funny to see that without the documentation, basically the LLM try to answer to this question, and I don't know why this particular model keep going in answering itself. So I cannot do that. You can do that in this way. Okay, so how can I do this other thing with my Canon, and so on and so forth. So it was funny, but yeah. Okay, just to get back here. Okay, so two particular. Sorry. This presentation, this demo is made of 2 main parts. The first one is the uploading of documents here, and the second one is the chatting part. So you can add your particular file and you can chat with them. The first pipeline is the first pipeline is the write pipeline, and you can add just with this pipeline the the documentation you have. So how this work? This is the scheme. It is not that complex how it look like. Basically, you can put your document, and the pipeline itself is able to route the document based on the source. So in this case, PDF or TXT. So the initial files are first of all converted. Then, in case you want to use this same pipeline, it is public in my public repository, so you can take it and use for other projects. The inputs are joined, so you can, for instance, give to this pipeline a folder with TXT and PDF, and the pipeline is able to take all the TXT and all the PDF and to convert and join them. After the joining phase, there is a preprocessing in the cleaning, so the cleaning and splitting of the docs text before the storage in the document store. There is the embedding phase, as I explained before, and then finally the docs are written in our document store, which is Quadrant. The other pipeline, which is fundamental, this one, the RAG pipeline, this is the very basic pipeline of RAG in Haystack. So the input text is first of all embedded. The text embedding is used for retrieve with Quadrant embedding retrieval. So each document store in Haystack has its own retriever. This one is Quadrant one. The documents are passed to the prompt builder, which builds the prompt that is then passed to the Hugging Face model. Here you can see that there is two phases where I call Hugging Face here in the embedding part with the Hugging Face API text embedder, here in the Hugging Face API generator. Then all these things are put all together, so the reply of the LLM, the documents of the retriever, the initial query, and the answer builder, which is another component, put all together and passed to the final user. So, RAGtime v2. This is a really basic, naive implementation, just to teaching purposes, as I said at the very beginning, but we can improve even better. So how can we do that? In the first part of the talk, there was the theory. Now let's get into more details. What can I do from the implementation? First of all, document management. I can, of course, improve a lot about database, so we can develop file update deletion process, and metadata augmentation, so we can add, for instance, a summary, a keyword list in my metadata to retrieve in a more efficient way. We can improve the generation, so testing new generator model, but even build a chat generator. So in this case, the memory is not properly handled, but we can add even this part of memory management. Function calling, that is another important part. I don't know if you have ever heard about function calling. Basically is a new method implemented first of all by OpenAI and then even Llama, but even other models. If I remember well, even Mistral in those days released the possibility to call the function calling, and it's really useful because together with RAG you can call even other external APIs if you want to add more context in your prompt. And yeah, of course, advanced or modular RAG implementation, so loops, new components, and so on and so forth. Those are useful resources. OpenRAG, if you are interested in this kind of topic, it's really great. There is a lot of papers, toolkits, readings, many more. Haystack Cookbook, if you want to build with Haystack, is a collection of notebooks with real-life application and experiments done by the Haystack team. And deeplearning.ai, I strongly suggest, because if you want to to have lectures of this kind of topics, not only RAG, but even the latest generative AI tools. It's less than an hour. The enrolling is for free, and to me, it's one of the best place to learn. Yeah, a bite on you, because I won't be here without them. This is my team. We are working on an advanced RAG implementation for company, which is called AIQ LX. If you are interested in RAGtime, in my company, in whatever you want to ask, I'm here. Feel free to ask. Thank you very much.
Thank you very much. That was great resource, great introduction to RAG. We have a lot of questions here. So first of all, how much more expensive is to run RAG for search compared to Elastic or Solr? Or is just price estimate for running a RAG?
I'm sorry, I'm not getting the Elastic Solr.
Elasticsearch, I think,
Elasticsearch, sorry.
Or Solr, and just a price estimate of how much it costs to run RAG, if you have.
Yeah, I think that that's a good question, because RAG is not for free. You can. Well, it depends. It depends on the kind of documentation, how many documents you want to retrieve, you want to store. But I think that with, for instance, AWS or with other services online, you can spend like, I don't know the real cost, but I think just the order of magnitude is hundreds of euros, dollars per year, if you are really, if you want to build a RAG in production, and if you want to make it effective in doing what it's doing. But even in my local laptop, it is possible to do that. So if you want to do with few documentation, or even do it in your local PC, is totally feasible. So yeah, it depends. It depends on what you are working on, a software or a personal project or an open source project for retrieving documentation. It depends. It depends.
Thanks. Next question is, can we leverage RAGs to prevent model to gaslight or make mistake, hallucinate?
Yeah, that's the that's the main reason why it is implemented. So they saw that with the recent event, there were a lot of hallucination in each model because of their own nature. So they are trained with publicly available data, so with even news, information, events, but it is impossible to use all the human knowledge. So yeah, RAG is implemented for this specific reason.
Exactly, for that. Yeah. Next question is, can I give my company's online documentation center, for example, Confluence or GitHub Wikis, to ask specific questions that need to compose info from different pages?
Yeah, of course, of course. I think this is one of the most powerful thing of RAG. You can combine even in different kind of, maybe I didn't stress out really well this point, but you can join even different sorts of information. You can convert Notion, you can convert Markdown files, you can convert PDFs and put them all together in a database, and you can select even maybe you are interested in some specific task to answer a question even from Notion, but not from PDF or reverted, and so yeah, absolutely.
Sounds good. We have time for one last.
Yeah,
and,
sure.
Will you be around for other questions, because there are other online? But
Sure, I'm here around here, so.
Cool. So the last question is, do you have a preferred chunking strategy? Would you recommend semantic chunking?
Okay, yeah, chunk. Really good question, because it's not that. Yeah, I strongly suggest to see all the different kind of chunking strategies in one of the paper I'm suggesting here, which is a survey, Retrieval Augmented Generation for Large Language Model survey. They have even a paragraph about chunking strategy. I think that the point in chunking is you have not to pass too many information, because otherwise the model will be more keen on confusing itself, and but even not less information, because otherwise it's different to bind them together. So yeah, I think there are many magical numbers here. There are people who says 200 words, who says 500 words, but I think that the real answer is it depends. It depends on what you are, the kind of the text, the kind of structured data you have. There is no general rule, but just experience. So it depends.
Thank you very much. That was awesome. Thank you.
You're welcome.